Yesterday we looked at exponential functions, and exponential functions had this type of form where the variable x is in the exponent. Remember from talking about exponents that the big number is called the base, and this would be called your exponent. And we looked at some of those graphs, and you have an example on your note sheet here. This blue line right here is an example of an exponential graph. That's the one that we looked at right up here, y equals 2 to the x power. And it's growing exponentially. It's exponential growth because the base number is greater than 1. Well, this graph is a one-to-one function, meaning that any x value you put in for that exponent, you will get a y value out. Since it's a one-to-one function, we can find its inverse. Okay, and if you think back to a chapter or two ago when we talked about inverses, you can find the inverse of a function by switching the x and y value around. So if we were to switch the x and y value around, you would then get the equation x equals 2 to the y power. And if you graph that out, you get this red graph right here. And that would be the inverse. Okay, remember inverse, basically all the points then would be switched. If you switch all the x and y's, all your points get reversed. If you look at the tables here, this point, the x and y get switched around 1/8 and -3. So you're just graphing the same numbers, just opposite directions, and you get the inverse. Well, this red graph and the blue graph kind of have the same shape. It's a reflection over this diagonal line, which is y equals x. And this red graph has a lot of the same types of numbers, again, just switched around. We call this graph right here, this red one, a logarithm. Okay, it's a logarithm. Or also you could call it a logarithmic function. And that's what we're going to be looking at the rest of this chapter are these logarithms. Logarithms are the inverse or opposite operation from an exponential equation. So they do all the opposite stuff of a exponential. So what is a logarithm? A logarithm is the inverse of y equals b to the x. That's what we looked at yesterday. So if you switch x and y, we end up with x equals b to the y power. This y is called the logarithm of x. So you get then this equation. Y equals this right here, log stands for logarithm. It's short for logarithm. Just kind of like when we did trigonometry, we took the word cosine and just wrote it as COS. Same with logarithm, we just kind of abbreviate it. This b right here is your base. Okay, just like we had a base of our exponent, we have a base of our logarithm, and x and y are the same x and y's as before. So if we use this definition of log, then these two things are actually equivalent. If you have log base d, this is again our base, that's the same base as right here. So the two bases are the same number, and x is the same number, y would be the same number. So you can switch back and forth between these two forms at any time you want. So if you kind of look at it, basically what happens is x doesn't move, x stays in the same spot. Okay, it's on the left side of the equation. B comes over and is now the base of our exponent, and y becomes the exponent. And that's how you switch between logs and base exponentials. So in number 1, part A, they want us to write this in exponential form. All right, so we want to use that same little conversion we just had. Log base b of x equals y is the same as x equals our base to the y power. So if we write this one in exponential form, 1 stays where it's at. our base of our exponent becomes the base of our our base of our log becomes the base of our exponential. This number becomes the exponent. So we can check if this is true or not. Does 1 equal 8 to the 0 power? Yeah, anything to the 0 power equals 1. Really, this is saying 1 equals 1. We did this problem right. Let's try another one. B. B wants us to write this one as an exponential form. Okay, so again, what we're taking the log of doesn't move. Okay, our base of our log becomes the base of our exponent. This number on the other side then becomes our exponent. So does 16 equal 2 to the negative 4th power? I think so, yeah. Remember we talked about if a number has a negative exponent, we can move that from the numerator down to the denominator and it becomes a positive exponent. And if you go on your calculator and do 2 to the 4th power, we do get that 1/16 equals 1/16. All right, I want you guys to try out C right now. So pause the video for a second, see if you can do C and see what you get. What would this one equal? All right, let's check it. If you did it right in exponential form, this one should be 16 equals base is 4 squared, and 16 does equal 4 squared. All right, so that's converting from log to exponential form. These problems in number 2 want us to do the complete opposite of what we just did, write this exponential in logarithmic form. So in logarithmic form, what we're going to write a log. Our base number of the log should be whatever the base of our exponent is. This is the base of our exponent, so 10 becomes the base of our log. What we're taking the log of is whatever this number would be, 1,000. And that should equal whatever this exponent is. So this one would be written log base 10 of 1,000 equals 3. Let's try another one. On B. This one wants us to do this one. So same thing here. If we want to write this the other way, if you're a little bit more comfortable writing it like this, you can do that too. Log 3. Okay, our base number has to be whatever number the base of the exponent is. Here's our base of our exponent. So that's our base of our log. So this should equal a half. All right, I want you guys to try out C. See if you can do C right now. So pause the video, try writing this one out in log form. All right, let's check it in log form. This one will be written as log base 125 of 5 equals 1/3. Now, these types of problems you can evaluate and kind of see if they're correct or not. These types of logs can be done on your calculator. So on your calculator, if you have like a TI-84 type calculator, how you would do that is you hit your math button, which is right under your second and alpha button. And if you keep going down to the bottom, there should be one called log base. If you hit that, this pops up. If you have a TI Inspire and you just find your log button, it should pop up automatically like this. So we want to type in what our base number is. If we look at the last problem we were just doing, it's 125, and what we're taking the log of is 5. So let's see if we get the same thing here. Let's type in 125. You got to hit your over button to get now to what we're taking the log of. If we hit 5 and move over now, hit enter, it tells us it's 0.33333333. Is that the same as 1/3? Yeah, if you hit your math button and select the fraction one, that is the same as 1/3. So yes, we correctly wrote that exponential in logarithmic form. All right, now some calculators may not have this written on. If you have like a TI-83 or one of those TI-30 calculators, it doesn't have the ability to type in the base number. So I will show you in a second how you can do that. So if we go on to number 3 here, they want us to evaluate each of these logs. So if we use the same thing we just did on the calculator, we should be able to do that. We want to do log base 2 of 64. So if you select math again, find our log base, we're doing log base 2 of 64. So that's what we want to type in. 2, hit over 64, hit enter, and this one tells us it's 6. So in this problem, y equals 6. And that should make sense. If you change this into the other form, remember this would say 64 equals 2 to the y power. The power of 2 that makes this true would be 6. 2 to the 6th power equals 64. So that's the answer here. Now, on a calculator such as a TI-83, if you go to your math menu, this one does not have that log base. However, it does have a log button on there. But this one won't allow you to type in the base. So another way you can do this on your calculator to find out what y is if you type log of the bigger number here, in this case 64, and divide it by log of the base number, which is 2, it'll also tell you the answer of 6. Now you got to be careful when you're typing this in. If you type this in your calculator, you're going to need to hit your log button, type in 64, make sure you close up the parentheses, hit your divided by button, hit the log again, hit 2, and then hit equals, and it should give you the answer. Well, let's just do it on here one time. So if you type this one in, log 64, close the parentheses up, divided by log 2, it gives us the same answer of 6. So that's a way, that's kind of a workaround you can do if you do not have the one that lets you type in the base. Let's try a few more of those. So the next one, they want us to find out what is log base 3 of 81, or another way of saying that is 81 equals 3 to what power? Well, we can type this in and figure it out. On the calculator, we can type this in, and we get log base 3 of 81. Looks like the answer is 4. 3 to the 4th power equals 81. So in this case, y equals 4. Why don't you guys try out C right now? Pause the video again, see if you can come up with the answer for C. All right, let's see what you got. If you did this one correctly, and do log base 4 of 256, you should get the answer of 4. 4 to the 4th power equals that. Okay, so that's how you can do logs on your calculator. All right, on the other side of your notes, there is a list of properties of logarithmic functions. We talked about already, it is a continuous function. It's one-to-one, meaning whatever x value you put in, you get a y value out. There's a couple other ones here that you can look through, but the big important one, and why I put this on here, is the second one. The domain is the set of all real positive numbers. Recall that domain is a fancy word for your x values. So this is saying log functions, your x value that you put in has to be a positive real number. And that makes sense. If we go back and look at the graph of this, okay, here's the graph, this red graph here. Look at the red graph. That's what it looks like. Here's the y-axis right here. Does this red graph ever cross over into this negative region over here of the x? No. It goes down here and it just keeps getting closer and closer to the y-axis. Well, what that means is if you have to put positive numbers in, you cannot do logs of any negative number. Try it on your calculator. If you type in log and put any negative number in there, and hit enter, it says you get a non-real answer because a negative number is not in the domain. Same thing goes with 0. You cannot do log of 0. It's not in the domain. 0, this red graph does not ever touch the y-axis, which means it never hits x equals 0. So you only can do log of positive numbers. It has to be bigger than 0 in order to do logs. All right, so keeping that in mind, we'll talk about that in a little bit. We're going to do some ones where we're going to solve with logs. So on 4a here, we want to know log base 4 of what would equal 5/2. Well, we don't want to just guess at this. And so what we can do is do the same thing you're doing on the other side. Change this from log form to an exponent, an exponential. So if we make that conversion, this equation becomes n equals our base of our log is 4. That becomes the base of our exponent. And our exponent becomes 5/2. Well, this is now something you can just type in your calculator to get the answer. So if we go on the calculator and type in 4 exponent button, now make sure you type your, some of your calculators, you need to type this in it with a parentheses if it doesn't pop up as a special exponent. Hit enter and you get 32. So in this case, n would be 32. So by changing from log form to exponent form, if you can't type this in your calculator to solve, then change it to exponent form. Let's try another one. B wants us to solve this one. Again, if we try just typing this in, we're stuck. We can't type in x and get an answer. So our thing we're going to do, change it to exponential form. X equals 9 is the base of our log, becomes the base of our exponent. 3/2 becomes our power. To do this one now, you can type it in your calculator, and if you type that one in to there, you should get 27. Why don't you guys try CL? Pause the video again, see if you can do that one. All right, let's check it out, see how you did on C here. On C, they want you to do this. Again, you're not going to be able to type this in because there's a variable over here. If you change to exponential form, you get 121 equals our base to our power of 2. All right, now to solve this one we can't just type in either, but we should be able to solve this. If b squared equals 121, we know that we can undo a power of 2 by taking the square root. So b would equal the square root of 121, which means b equals 11. Square root of 121 is 11. All right, let's try some of these problems now with inequalities. If it's an inequality, you want to solve it just like we've been doing the last problem. So check this out. Can we type this in our calculator? Nope, we got a variable x there. So what we're going to have to do is change to exponent form. In exponent form, this would say x, keep the symbol the same. The base of the log is the base of our exponent. This number 2 becomes our exponent. So x is less than 5 squared is 25. Now, this answer, most of the number, or a lot of the numbers you put in less than 25 will work here. However, if it's all the numbers less than 25 that should work, that means one of the numbers that should work would be -10. -10 is less than 25. Well, what happens if we try putting this into our calculator then? Let's try it out. What happens if we do, this one was base 5. Let's try log base 5 of -10. And some of you might already know the answer. Can't do this one because you can't do logs of negatives. So it's not, the answer on this one is not all the numbers less than 25. You got to remember the domain of this again is that x has to be positive, which means it has to be greater than 0. So what we need to add on to our answer is that, yeah, it needs to be less than 25, but it also needs to be greater than 0 so that you don't get log of negatives or log of 0. Let's try another one. B. This one wants to know what is this one. So can't type this one in our calculator, change it to exponential form, keep the symbol the same. Base of our log becomes the base of our power, 3 becomes the exponent. If you type in 4 to the third power in your calculator, you get 64. So x has to be greater than 64. If x has to be greater than 64, it's always positive. We don't need to add anything about being bigger than 0 because this will automatically stay bigger than 0. Why don't you guys try C right now? See if you can do C. Pause the video, try this one out. All right, let's see what you got. On this one, if you change the exponential form, 2 is the base, 4 becomes the power, 2 to the 4th power is 16. Will all the numbers less than 16 work for x? Nope. Remember, we need to stay greater than 0. So these ones with inequalities are pretty similar to the ones with equal signs. The only thing you need to do is if it happens to be less than, you need to add on that it needs to stay bigger than 0. All right, last couple questions here. We're going to look at some solving ones in the next couple of days of how you solve with logs. Well, the thing with logs is if you have a log or a logarithm on both sides and the base number is the same, and you only have one log equals one log, or one logarithm equals one logarithm, just like a lot of things in math, you can cancel those out. But it has to only be one logarithm equals one logarithm, and the base number has to be the same to do this. So if they're both the same, we can cross those out, and then basically we just have to solve what's left over. So we got to solve x squared minus 2 equals x. If we solve this out, we will find our answer. Well, this one doesn't solve all that easy. It is a quadratic problem, it looks like. We want to get quadratic problems equal to 0. So let's minus an x over. So now we have x squared minus x minus 2. Well, we've done these problems a while now. What multiplies the negative 2 and adds to negative 1? Negative 2 and positive 1. So this is going to factor to x minus 2, x plus 1. Set those both equal to 0. Solve, and we'll get our answer. Looks like x has to be 2 or x has to be negative 1. Do both answers work? You got to check to see that both answers work. One of these answers does not. Okay, 2 will work out fine. If we do 2, we can do log of 2. We can do log of, this would end up being also 2. That's okay. If you put in negative 1, can we do log of a negative? No. That's why this answer does not work. 2 is the only number that works on this one. So sometimes you might get an answer that doesn't quite work for our problem. All right, let's try another one of those. Let's try B. Okay, again, we got log on both sides, same base. We can drop logs out of our problem. So our problem becomes x squared minus 15 equals 2x. Another quadratic problem. Looks like we need to get it equal to 0. It would become negative 2x if we minus it to the other side. This one does factor. Well, it multiplies the negative 15, adds a negative 2, negative 5, and positive 3. If you set those both equal to 0 and solve, looks like we get two answers of 5 and negative 3. Do both answers work? Nope. The negative 1 won't. If we put negative 3 in here, we'll end up doing log of negative 6. That's no good. Can't do logs of negatives. 5 is okay. If we put 5 in there, both of them stay positive. So the only answer is 5. All right. Why don't you again pause the video, try C out, and then check your answer. All right. Let's see if you did C right. We can again drop the logs out because they're both log base 14. If you solve what's left over here, you're again going to need to get it equal to 0. And if you solve this one out by factoring, you should get an answer of 6 and negative 5. However, the negative 1 does not work. Only 6 is an answer here. All right, why don't you try out some more of these logarithm problems on your worksheet.